Example 2. Read the example. In this example, we see that there are 2 places we could insert the word per. And remember, the word per, each, every indicates a rate. Here we have $10 per hour for babysitting, and we have $20 per hour for tutoring. And then we're given a total amount of money that she wants to have to buy a computer. So that means you're saving at least $1,000 by earning $10 per hour for babysitting and $20 per hour for tutoring. So the 2 unknowns in this situation would be, how many hours is she going to spend babysitting? And then how many hours is she going to spend tutoring? So we're going to let our variables X represent the number of hours spent babysitting, and Y will represent the number of hours spent tutoring. And then if you tutor for 1 hour, how much money will you earn? Well, you'll earn $20. If you tutor for 2 hours, you'll earn $40. 10 hours, you'll earn $200. So what are we doing with the Y value, the number of hours you spent tutoring, and the number 20? We are multiplying. So if it's $10 per hour for babysitting, and we let X represent the number of hours babysitting, and it's $20 per hour for tutoring, and we let Y represent the number of hours for tutoring, 10X represents how much money she'll make through babysitting, 20Y represents how much money she'll make through tutoring. When we add those 2 values together, we'll get the total amount of money she has saved. How much money does she want to save? She wants to save at least $1,000 so that she can buy the computer that she wants. Well, at least means the lowest amount, the minimum is $1,000. It would be okay if she saved more than $1,000. So the lowest amount can be equal to $1,000, but obviously with money, it's okay if you earn more. So let's look at the graph of this inequality. This is an inequality because the amount that she wants to save is not exact. And in many situations with money, inequalities are more relevant because we could have a range. So graph the inequality, be sure to label the axis. So you want to think about scale. And you want to think about, what does the X and Y represent? Well, we've already determined that X represents the number of hours babysitting, and Y represents the number of hours tutoring. In order to graph this, I'm going to find the X and the Y intercept. Once I find the X and the Y intercept, then I'll decide what I want my scale to be. So remember, the X intercept is a point on the X-axis, and all the points on the X-axis have a Y value of 0. If I substitute 0 for Y, I'm left with 10X equals 1,000, and therefore X would be equal to 100. To find the Y-intercept, you would substitute 0 for X. When you substitute 0 for X, you're left with 2Y equals 1,000, 20Y, excuse me. And if 20Y equals 1,000, divide by 20, and Y would equal 50. What do these points tell me? They tell me that if she's only going to, X represents babysitting, if she's going to babysit only, she'll need 100 hours of babysitting to earn her minimum amount of $1,000. If she's only going to tutor, she only needs 50 hours of tutoring. Based on this, I'm going to let my scale on the X-axis go up by tens. So each tick mark will represent 10. I'm going to label every other one so that it's obvious what my scale is. And we know that 100, 0 is the x-intercept. On the y-axis, I'm going to go up by 5s because the y-intercept is not as large as the x-intercept, so I can go up by 5s and still have enough room to plot the y-intercept. And we know that the y-intercept is 0, 50. If we did the rate of change, we would see that we have to go down 50 over 100 for the rise over run. So the slope would be negative 50 over 100, which simplifies to negative 5 over 10, which works perfect with my scale. I can go down 5, so one box represents 5 on the y-axis, over 10, one box represents 10 on the x-axis, and that would be how I could apply it and find more points on the line. This is an inequality, so I need to think about dashed or solid line. A dashed line would be these points that I just plotted, which make her come up with exactly $1,000. 10 times x plus 20 times y for all the points I just plotted would be exactly $1,000. So for example, if she worked 20 hours babysitting, she would need 40 hours of tutoring to get exactly $1,000. Are those points solutions? Would they work with this situation? Well, she said she needed at least 1,000, so 1,000 would be acceptable. So the points on the line are solutions. So because it can equal 1,000, we're going to use a solid line to represent that the points on the line are solutions. To decide which side of the line to shade, we can use a test point. If I test the point 0, 0, and I plug it into the inequality, I'm going to plug it into that original inequality. Even if you solved for y and put it into slope-intercept, it's still a suggestion to go back and plug it into the original inequality. 0 plus 0 greater than or equal to 1,000. Obviously, that is not true. She cannot work 0 hours for both jobs and get her $1,000. So that means the solution would be on the other side of the line. You would shade away from 0, 0, indicating that all of the points on the other side of the line would work as solutions to this inequality. Using the graph or the inequality, we can answer questions C and D. If Sarah babysits 33 hours, so remember babysit was x, so here we would be saying that if x equals 33, then what must y equal, or what must y at least be in order to meet her goal? So if I substitute that into the inequality, 10 times 33 plus 20y is greater than or equal to 1,000. Solve. 330 plus 20y greater than or equal to 1,000. Subtract 330 from both sides. 20y is greater than or equal to 670. Divide both sides by 20, and we get y would have to be greater than or equal to 33.5. So she needs at least 33.5 hours of tutoring if she's going to babysit only 33 hours. We could go back and look at the graph as well. A little harder since we have 30 to 40. We have a scale of 10, so 33 would be somewhere in here. So it would be less likely to be precise. We wouldn't really be able to tell that that's 33.5, a minimum for the tutoring hours. So it's better to use the inequality to solve algebraically. Find the minimum number of hours she must babysit if she tutors for 17. Tutoring was our y value, so if y equals 17, what must x equal? So again, we've got 10x plus 20y. Y is a value of 17. Substitute 17 for y. Solve the resulting inequality. 20 times 17 is 340. 10x plus 340 has to be greater than or equal to 1,000. Subtract 340 from both sides. 660. Divide by 10 and we get x has to be greater than or equal to 66. So if she's going to tutor for 17 hours, she has to babysit for at least 66 hours. This would be an example of a linear inequality with a real-world scenario. Now work through the practice problems on the attached sheet.